Example 3, Part A. Set up an integral for the length of the arc of the hyperbola x y equals 1 from the point open 1 and 1 close to the point open 2 and 1/2 close. Part B. Use Simpson's rule with n equals 10 to estimate the arc length. Solution. Part A. We have y equals 1 over x, dy over dx equals negative 1 over x squared. And so the arc length is big L equals the integral from 1 to 2, the square root of 1 plus open dy over dx closed squared dx equals the integral from 1 to 2, the square root of 1 plus 1 over x to the fourth power dx equals the integral of 1 to 2, the square root of x plus 4, the square root of x to the fourth power plus 1 over x squared dx. Part B. Using Simpson's rule, see section 7.7, with a equals 1, b equals 2, n equals 10, square root, delta x equals 0.1, and f of x equals the square root of 1 plus 1 over x to the fourth power. We have big L equals the integral from 1 to 2 times the square root of 1 plus 1 over x to the fourth power dx, which is approximately equal to the delta x over 3 times open bracket f of 1 plus 4 f of 1 plus f of 1.1 plus 2 times f of 1.2 plus 4 times f of 1.3 plus ellipsis plus 2 times f of 1.8 plus 4 times f of 1.9 plus f of 2 close bracket is approximately equal to 1.1321. Sidebar. Checking the value of the definite integral with a more accurate approximation produced by a computing device, we see that the approximation using Simpson's rule is accurate to 4 decimal places. The arc length function. We will find it useful to have a function that measures the arc length of a curve from a particular starting point to any other point on the curve. Thus, if a smooth curve big C has the equation y equals f of x, x is greater than or equal to a but less than or equal to b, let s of x be the distance along big C from the initial point, big P sub naught, open A, and f of A, close, to the point big Q, open X, and f of X, close. Then S is a function called the arc length function, and by formula 2, equation 5, S of X equals the integral from a to x times the square root, restarting that line, equation 5, s of x equals the integral from a to x, the square root of 1 plus open bracket f prime of t close bracket squared dt. We have replaced the variable of integration by t so that x does not have two meanings. We can use part 1 of the fundamental theorem of calculus to differentiate equation 5 since the integrand is continuous. Equation 6, ds over dx equals the square root of 1 plus open bracket f prime of x close bracket squared equals the square root of 1 plus open dy over dx close squared. Equation 6 shows that the rate of change of s with respect to x is always at least 1 and is equal to 1 when f prime of x, the slope of the curve, is 0. The differential of arc length is equation 7, ds equals the square root of 1 plus open dy over dx closed squared dx. And this equation is sometimes written in the symmetric form. Equation 8, open ds closed squared equals open dx closed squared plus open dy closed squared. The geometric interpretation of equation 8 is shown in figure 7. It can be used as a mnemonic device for remembering both of the formulas 3 and 4. If we write big L equals the integral of ds, then from equation 8, either we can solve to get equation 7, which gives equation 3, or we can solve to get ds equals the square root of 1 plus open dx over dy closed squared dy, which gives equation 4. Sidebar, see figure 7. Back to the text. Example 4. Find the arc length function for the curve y equals x squared minus 1 over 8, the natural log of x, taking big P sub naught open 1 and 1 closed as the starting point. Solution. If f of x equals x squared minus 1 over 8, the natural log of x, then f prime of x equals 2x minus 1 over 8x. 1 plus open bracket f prime of x close bracket squared equals 1 plus open 2x minus 1 over 8x closed squared equals 1 plus 4x squared minus 1 half plus 1 over 64x squared equals 4x squared plus 1 half plus 1 over 64x squared equals open 2x plus 1 over 8x closed squared. The square root 1 plus open bracket f prime of x closed squared equals 2x plus 1 over 8x. Since x is greater than 0, thus the arc length function is given by s of x equals the integral from 1 to x, the square root of 1 plus open bracket f prime of t close bracket squared dt equals the integral from 1 to x open 2t plus 1 over 8t dt, I should say close dt, restarting that line. The integral from 1 to x of open 2t plus 1 over 8t close dt equals t squared plus 1 over 8, the natural log of t on the interval from 1 to x equals x squared plus 1 over 8, the natural log of x minus 1. For instance, the arc length along the curve from open 1 and 1 close to open 3 and f of 3 close is s of 3 equals 3 squared plus 1 over 8. The natural log of 3 minus 1 equals 8 plus the natural log of 3 over 8 is approximately equal to 8.1373. Sidebar, figure 8. Figure 8 shows the interpretation of the arc length function in example 4. Figure 9 shows the graph of this arc length function. Why is s of x negative when x is less than 1? In figure 8, we have s of x, point, big piece of knot, and y equals x squared minus 1 over 8, the natural log of x. Figure 9. Figure 9 shows the graph of this arc length function. Y is s of x negative when x is less than 1. S of x equals x squared plus 1 over 8, the natural log of x minus 1.